Hey my friend, welcome to Joy's Dynamic Programming tutorial. You are watching the 100th video of dynamic programming on my channel Joy's Tech. Thanks for all your support. Your comments and acknowledgements really encourage me to keep going and work harder so that I can bring out instructional videos for you on programming and algorithms that really help you succeed. In this video, you will be learning the arithmetic slices problem, which I have taken from the Leetcode website. Let's see what its problem statement has to say. You must have heard about arithmetic progression. This DP problem is very much related to that. The problem says that if an array consists of at least 3 elements and if the difference between any two consecutive elements is the same, then that array is called arithmetic. So you are given this array nums over here. You need to find out the number of arithmetic subarrays from this array. For example, 1357 is one arithmetic subarray, and so is 135. We'll find the solution of this problem using the classic dynamic programming technique, but before we do that, do subscribe to my channel if you haven't done it already and hit the bell icon, as that way you won't miss out on any of the videos I release. As you can see that I have put down the problem array over here. Beneath it, I have created another array which goes by the name DP. This will help us determining the solution. The clue that the problem statement provides is that the array has to have at least 3 elements to be arithmetic. Hence, in the first 2 cells of this array, I'll simply pour zeros and will start the operation from this cell, the third cell. Let me put zeros in these cells now. To fill the value in this cell, we'll do a simple operation of checking whether the result of the subtraction of 5 and 3 matches the subtraction result of 3 and 1. This is what is going to make it a simple arithmetic subarray, right? So 5 minus 3 is 2 and 3 minus 1 is 2. They both give the same result. So all I'll do is add 1 to the value stored in the previous cell and store the calculated result in this cell. Why we did it, you will find out in the next sub-problem. One thing is clear, that we have got an arithmetic slice over here, and for the purpose of clarity, let me write that arithmetic slice down here. Moving to the next cell, we perform the same operation here. The result of 7 minus 5 is 2 and the result of 5 minus 3 is 2. So they both match. In this case, what we are going to do? We'll add 1 to the value stored in the previous cell and store the calculated result here in this cell. Thus, I populate 2 here. Now, this 2 means that there has to be 2 arithmetic slices. Shouldn't there be? The first arithmetic slice will obviously be 3, 5, 7, which we already checked just now. But which is going to be the next one? So let me tell you that it will be 1, 3, 5, 7. This particular arithmetic slice we got from the previous subproblem, which already found out 135, and the new addition is 7 to the series. Now, if you consider the subproblem till here, you can see that we have 3 arithmetic slices in total, which can be simply calculated as a result of the addition of 1 and 2. Let me write a variable here and store 3 as its value. Let's perform the same operation for this cell as well, as we are very close to finding our final answer. So here the subtraction result of 9 and 7 will be 2 and the subtraction result of 7 and 5 will be 2. They both match. So in this case, what we are going to do, we will add 1 to the value stored in the previous cell, as a result of which we are going to get 3, and I'll store 3 in here in this cell. This 3 denotes that there are 3 arithmetic slices or 3 arithmetic subarrays involving 9. So the first one is very simple. It will be 5, 7, 9, which we just checked. The second one can be found out by simply adding 9 to this arithmetic slice over here, which is going to give us 3, 5, 7, 9. And the third one can be found out by simply adding 9 to this arithmetic slice over here. That is going to give us 1, 3, 5, 7, 9. So there you go. So the total number of arithmetic subarrays that we are going to get out of this array nums will be 6. So this 3 over here will be added to the value of the variable res, which is already stored over here, and it is going to give me 6. There you go. We have solved this problem using dynamic programming technique. You'll find the GitHub link to the Java solution of this problem in the description box below. I hope you enjoyed watching this video. Like it, share it, tell people about it. I look so much forward to help you with programming and algorithms. Thank you, and take very good care of yourself.